Our next talk is on mod anti-malware, and it's presented by Neil Daswani. Neil is a co-founder and CTO of Daswani, and prior to that he ran a part of the security team at Google, and he also co-founded Advanced Security Certification Program at Stanford. Please give a warm welcome to Neil.
Thank you, Michael. Very good. So I'll be talking today about mod anti-malware, a pretty exciting web server module that we've built at Daswani for both Apache and IIS, and we'll talk about web-based malware infections in general. We'll talk about structural vulnerabilities on websites, and we'll of course talk about the module itself as well as its design and architecture. But before I get into the meat of the material though, what I would like to do is just let you know that we're going to have a couple giveaways at the end of the talk. So I published this book, Foundations of Security, while I was at Google, and I'll be raffling off a copy at the end of the talk. In addition, I'm not quite sure how many folks have heard of Daswani. We started in late 2008, so while the world's legitimate economies were falling through the floor in late 2008, the world's cyber criminal economies were of course going through the equivalent of a boom, and we had raised our first round of financing at that time from a pretty well-esteemed group of folks. And so what I'll be doing is at the end of the talk I will be raffling off some or actually I'll just be giving out some passes to a private party that we're throwing this evening. At Daswani we have been working with a variety of companies, a variety of customers, and I'll tell you a little bit about what Daswani does as a business just kind of throughout the course of this talk, but I'm going to be specifically focusing on mod anti-malware. So let's see, if anybody, by the way, has any questions, and this is kind of a big room, but if anybody does have questions, feel free to raise your hand. I'm not quite sure if we have mics, but I'd be happy to take questions. In fact, I may reserve, say 10, 15 minutes at the end of the talk specifically to focus on questions that folks might have. So with those preliminaries out of the way, let me go ahead and get into the meat of the matter. The work that I'm going to be presenting on mod anti-malware is joint work that has been done together with a number of other folks at Daswani. So one thing that I want to mention is that the way that malware has been spreading on the internet has fundamentally changed over the past few years. It used to be the case that most malware would spread as, say, attachments to email, and people would get infected when they clicked on the emails, and it would go into their contact list and spread to other folks in their contact lists. Of course, what's happened over the past 3 to 4 years is that an increasing amount of malware is getting spread by compromising legitimate websites. And I'll talk about a number of the different ways that legitimate websites are getting compromised, but the key thing that the attackers are doing is taking legitimate websites and turning them into distribution vehicles for their malware, such that when users happen to visit compromised legitimate websites, they will simply get infected just by loading the page in their browser. And because of the virulence of these attacks, the major search engine providers, the major browser companies, the major traditional antivirus players have been taking a very aggressive stance with regards to addressing drive-by downloads as well as other forms of web-based malware. So these attacks have not only been hurting users, but they've also been hurting the enterprises and the websites that are effectively being used as the intermediate victims in these types of attacks. So there's a number of negative ramifications that the businesses, enterprises, websites suffer from when their websites get compromised and turned into a delivery vehicle for malware. So for instance, I'll give a couple examples. When a website gets infected and is used to spread web-based malware, drive-by downloads and the such, Google as well as major search engines will do things like in their search results, they will add annotations to the search results saying that this site may harm your computer. And if users attempt to simply even click on those links, instead of taking the users to those sites, Google, for instance, will return an interstitial page which will say, really, we're not kidding, this site's going to harm your computer. You should think very hard before going there. In fact, when Google initially released those interstitial pages, they still used to include a link to the infected websites, and they found that so many users still clicked on that link anyway that they took the link off. So that's one thing that Google's doing, but basically if you look at Yahoo, for instance, in their search results will flag sites that are sending down dangerous downloads. If you look at Microsoft's Bing, the smart screen filter technology that's built into the IE browser is also used to send information to Bing such that users can be protected from malicious websites or compromised websites in the search results. In addition, the information about these compromised websites is being shared with browser companies. So if you look at Firefox, if you look at Chrome, if you look at Safari, they are incorporating data from Google and other sources about websites that have been compromised and infected. And when a user attempts to get to any one of those sites simply by browsing, casual surfing, as opposed to going through the search engine, they will, instead of seeing a website that might infect their computer, they'll see a red screen of death. So for instance, in Firefox, it'll show this screenshot up here on the left saying reported attack site, don't go there. And there's been a whole variety of businesses, small, medium, and large, that have had such issues. To give a couple of examples, this past May, the US Treasury website had gotten infected, and they in fact had to take down some of their websites due to these kinds of infections. But it's been happening to a whole variety of organizations. So what happens is when these kinds of warnings are added to search results or these red screens of death are shown by browsers, it results in a very significant traffic loss for websites. There's some websites that might receive, for instance, 90 to 95% of their traffic from Google. And if the sites won't get served in the search results in the traditional way, then they can lose quite a bit of traffic. In addition, if the website is, say, an e-commerce site and they're selling services online or selling products online, then they effectively lose their ability to sell when these kinds of issues occur. If they're an online publisher that makes their revenue through ads on the site, then their ability to earn revenue from those ads also gets curtailed if users cannot find their way to those websites. So traffic and revenue loss is one of the major issues that occurs when web-based malware spreads. I had mentioned that in addition to the search engines and the browsers, there's the traditional antivirus players that are also taking a very aggressive stance to this. So if a user ends up at an infected website, however they get there, their client-side antivirus package may pop up a warning saying threat detected. That's, for instance, the warning that AVG will display when a user tries to get to a site. And it also, in addition to traffic and revenue loss, can just result in brand damage. People get scared to go to that site. In addition, there's a whole bunch of data theft and compliance liabilities that can occur. In fact, what I'd expect to happen over the next few years is that when businesses get impacted, what's going to happen at some point is there's going to be a lawyer that's going to inevitably end up at an infected website. A drive-by download is going to occur. That lawyer's machine is going to get infected. They're going to blame the website. They're going to sue the website. They're going to create a class action lawsuit, and the website that got compromised and turned into an intermediary victim for serving drive-by downloads and other web-based malware is going to get sued by that class action suit. So it's just a matter of time before these things happen. So web-based malware can significantly hurt enterprises. And so now that I've talked about the negative ramifications, let me talk about how these infections occur. And I am going to focus on a variety of infections. There's some types of infections and infection vectors that are more traditional than others, but let me talk about both the traditional as well as the non-traditional ones. So Looking at one vector of vulnerability, let's start with software vulnerabilities. Websites and web applications may have all kinds of software vulnerabilities in them. The website, if it's connected to a database, it may be vulnerable to a SQL injection attack. If the website happens to, say, take user input, even if it isn't connected to a database, it can be vulnerable to a cross-site scripting attack. If it's connected to a database, it could be vulnerable to a stored cross-site scripting attack. And bad guys can use those types of vulnerabilities not simply to steal data, as they have been used in very traditional ways, but those vulnerabilities can be used to inject malicious code into the databases that run the website. So what can happen is that the bad guys will inject malicious JavaScript and malicious iframes, say, into the header and footer of a website that happens to be a blog, or part of a website that happens to run a popular blogging package. There's also things like shopping carts, e-commerce packages. There's a whole variety of third-party applications that are used. And so that's one way that websites can get infected, through traditional web-based software vulnerabilities. For those of you that are familiar with the OWASP top 10, you know that those types of vulnerabilities can be used to inject data into a website and turn it into a malware delivery vehicle. In addition to software vulnerabilities, though, there's a whole bunch of other types of vulnerabilities as well. And one of the interesting things about web-based software vulnerabilities is that one can run a traditional vulnerability assessment, web-based web application vulnerability assessment, to find these issues and fix them and mitigate them. And of course that takes some time, but it's very doable. At the same time, there's a set of vulnerabilities that are not as easily preventable. And let me talk a little bit about what's been going on with Web 2.0 and external content and third-party dependencies. So one of the interesting trends that we've seen over the past 5 to 6 years with Web 2.0 is that no website exists in a silo anymore. Websites use a lot of third-party resources to bring their site together. So a website might have a page that's constructed with a set of mashups, a set of widgets, which include code, say JavaScript code or ActiveX code or whatever code from some other website. And one of the interesting things about this Web 2.0 trend is that if you look at many sites, they rely on a lot of third-party resources. And so you can think of these as issues where let me talk about how malware relates to this. So basically, if a piece of malware or if a bad guy or a cybercriminal compromises a widget that happens to be used by thousands of sites, then basically that widget effectively allows the attacker to distribute their malware to all those thousands of sites that use the widget. Now this is an interesting kind of vulnerability. This is a kind of vulnerability that is not a software implementation vulnerability, but is a structural vulnerability. And we at Daswani, we issued a research report just earlier this week on structural vulnerabilities. I'll spend a little bit of time about structural vulnerabilities, and then I'll talk about how mod anti-malware addresses structural vulnerabilities as well. But the key point here is that with Web 2.0 and the reliance on a lot of third-party resources, including widgets, including ads of various kinds, if the bad guys compromise those widgets, if they compromise the ads, then what happens is that every website that uses those widgets and ads also basically can be used to spread malware. So that's one thing that's very interesting about how the web has become more interconnected, and how Web 2.0 has, to an extent, increased the attack surface, and how